And I think we are live. Cool. We're live and well. So, hello everyone. Welcome to the OneClass channel. My name is Millen, and I am a software engineering student at Carleton University in Ottawa, Canada. Today we'll be going over some commonly asked mathematics questions at both the high school and college levels. And if you need some help tutoring or with your homework, check out the links in the description below. Alright, so let me switch my screen over to our first question. Okay, so here we go. The first question that we want to deal with today is, what is the derivative of log x? Let's write that out in a more mathematic type language. So let's draw it out. D over dx, meaning we're taking the derivative of log x. Now, how do we deal with this? Well, this is one of those differentiations that you're kind of going to need to really keep on your tool belt real nice and handy, because it is likely that you will see this rather commonly. But the result of this is we are going to do 1 divided by the logarithm, the natural logarithm of the base multiplied by what's inside. Like, what I mean by inside is like inside here. And then we need to multiply this whole thing by the derivative of what's inside because of the chain rule. Don't forget the chain rule. Okay, so a good thing to note is that with logarithms, we're often going to see a base most of the time. Let's call that base b. This base b is what is going there for your information. Now, if the logarithm doesn't specify a base, so we just have log here, like log no specified base of x, what that means is we have to assume base 10. If there is no specified base, assume base 10. Okay, so in the question that we're giving, we have no specified base, meaning that we have a base 10 situation right here. So this equation is good, but let's do this, but with the example that we have here with base 10. So the derivative of logarithm x is equal to 1 divided by the natural logarithm of 10, that's the base, multiplied by x. Here, because of the chain rule, we got to multiply with the derivative of what's inside here, but we know that the derivative of x is just 1. So this entire thing here, that simplifies out to 1 in this case. So we actually don't need to write anything for that. And this would be our complete solution right here. The derivative of logarithm of x with no specified base of the log, that means we're assuming base 10. The result of that is 1 divided by natural logarithm of 10 multiplied by x. Now, something I want to mention is that, let's say we had a different base that looked like this. Log maybe base 2 of x. Send that through the differentiation, and we will have 1 over natural logarithm of 2 times x. Okay, that makes sense. It follows the rules. But something I want to mention, a ln, or natural logarithm of x, is equal to regular logarithm with base e, which is which you could also write as like natural logarithm or logarithm of 2.718. It's a big long number. So when we do this, we know that the derivative of natural ln of x, that is going to be following our log strategy here. We have the result of that is 1 divided by natural ln of the base. In this case, the base is e. E stands for Euler's number. From a guy named Euler a long time ago, he was trying to figure out compound interest calculations, and that's how he figured out what e was. Fun fact. And then multiplied by x. Send that through your calculator and tell me what you get. Natural logarithm of e, which is the base, is 1. So that's equal to 1. So this is just 1 over x, which is why the derivative of natural logarithm is 1 over x, whereas the general rule for taking the derivative of a log, regardless of the base, is 1 over natural log of the base times x on the denominator. Yeah. So to verify the solution that we have here on OneClass, yep, they got the general formula for logarithm. You put the natural log on the bottom of the base multiplied by what's inside, and of course they would have like the internal derivative of the argument to log if this was something more complicated than just x. But with base 10, it looks good. So we can approve this solution. The above solution is correct. Cool. Super. Okay. So let's clear out